Welcome back to the How Long segment of the lesson. In working with the discounting numbers in your spreadsheet, did you see how the discount rate and the present value seesawed? It's really powerful to know that when a rate goes down, the PV goes up, and vice versa. When you learn to do these calculations on a calculator, in a future lesson, it will be important to know this, so you'll catch errors. It's surprising how important this is. But for now, let's move on to the time element of the equation, n per. Now, in the last segment on discounting, I simplified the compounding equation for our purpose by moving the unknown PV to one side of the equation and all the known values to the other side. Let's look at that for a second. Okay, now let's go back to the original compounding equation that I put on the top of this page. Here, we want to solve for n per. But there really isn't any way to simplify the equation for this purpose like we did when we were working on discounting. We could convert the first equation to the second one shown here, but that doesn't get us very far. FV divided by PV equals 1 plus rate to the power of n per. But we still have to solve for n per. Here's a little secret. The only way to solve for the time element n per, if you're not a mathematician, is trial and error. I'm not kidding you. Even the spreadsheet uses a trial and error method. But it's faster than you or I. You sometimes see the delay, a second or two, rather than instantly. But a second or two is better than the week it would take me to do the calculation on paper. Well, maybe it would take 5 minutes. But that's a lot worse than a second or two. Let's take a look. In row 1, I've used the same numbers we've been using all along so that you can see that it is still the same equation with the same answers. I have a starting investment of $10,000, which I'm putting into a 5% CD. My financial goal is still $16,289. I want to buy a smart car. How long will I have to wait for my 10 grand to grow to this amount? The spreadsheet tells us 10 years, which is what we've been saying all along. In row 2, I'm going to do the same thing we've been doing with the other spreadsheets, testing out what happens if I change a number. So in row 2, I'm going to decrease the growth rate from 5% to 3%. And the time needed to reach my goal has now jumped from 10 to 16.5 years. It's another seesaw. The rate goes down and the time period goes up. Let's try 8% in the third row. Here we're going to see the other side of the seesaw. I increase the 5% to 8%, and the time period decreases from 10 years to 6.3 years. Makes sense, no? The faster your investment grows, the less time you have to wait to reach your goal. Can we see this in the equation? This one's a little harder, but it's there. If we look at the lower version of the equation on the screen, we see that with these numbers, FV divided by PV is a constant 1.6. That's $16,289, the goal, divided by $10,000, the original amount. And that comes out to about 1.6. It's the same for all three rows. So if I decrease the rate, I I have to compensate by increasing n per and vice versa in order to get a constant answer on the left side of the equation. Now you try it using the How Long tab of the spreadsheet you've been working with. This concludes the How Long segment of this lesson. When you are done working with the spreadsheet, please continue with the Rate Needed segment of the lesson.